In this video, we will discuss few more important and repeated questions from the topic time, speed and distance. And we will discuss few questions related to police and thief. First one, a policeman spots a thief 120 meters ahead. Immediately, the policeman starts chasing the thief. See, here is the thief, okay, and here is the policeman. The policeman spots a thief 120 meters ahead. See, the distance between them both is 120 meters. Okay, so the thief is moving in the opposite direction of the policeman like this, and the policeman is chasing the thief. Okay, and the policeman runs 26 meters in a minute, and the speed of the policeman is 26 meters per minute. Okay, and the thief runs 20 meters in a minute. The speed of the thief is 20 meters per minute. Okay, in what time will the policeman catch the thief? Okay, here we will assume this is a point X. At this point X, the policeman will catch the thief. Okay, so we will assume the distance traveled by the thief is D. Okay, so the distance traveled by thief is D. Okay, and the policeman traveled from this point P to X. So he traveled 120 meters plus T. The distance traveled by policeman is 120 plus T. Okay, so the distance traveled by the policeman is 120 meters more than the distance traveled by the thief. So if we subtract the distance traveled by policeman and the distance traveled by thief, we will get 120, right? And what is the time taken? The time taken by the thief to travel from point T to X is equal to the time taken by the policeman to travel from point P to X. Okay, so here the time taken by the thief to travel from point T to X is equal to time taken by the policeman to travel from P to X. Okay, so we will assume the time taken is equal to T. The time taken is equal to T. So what is the distance traveled by the policeman? Distance is equal to speed into time. What is the speed traveled by the policeman? It is 26 meters per minute. Speed into time is T minus distance traveled by thief is what? And speed of the thief is 20 meters per minute into time is equal to 120. Okay. Here 6T is equal to 120. T is equal to 20 minutes. Okay. It is second option. Next one. Excluding the stoppages, the speed of the truck is 90 kilometers per hour. Okay. The speed of the truck without stoppages is 90 kilometers per hour, and including the stoppages, the speed of the truck is 36 kilometers per hour. So speed of the truck with stoppages is 36 kilometers per hour. So what is the difference in the speed? Difference in the speed is 90 minus 36. It is 54 kilometers per hour. Okay. So what is the stoppage time per hour? In 1 hour, how much time it stops? It is difference divided by speed without stoppage. Difference divided by speed without stoppage. This is 9 into 10, 9 into 6. Okay. 2 into 3, 2 into 5. It is 3 by 5 hours. Okay. We have to find this in minutes. So we will multiply this with 60. Okay. Here 5 into 12. It is 36 minutes. Answer is 36 minutes. Second option. Next one. In a circular race of 5000 meters starting from the same point, the speeds of two contestants A and B are 36 km per hour and 54 km per hour. The speed of A is 36 km per hour and speed of B is 54 km per hour. Okay. The difference between the time taken to meet for the first time when they are running in opposite direction and when they are running in the same direction. Okay. If they are running in opposite direction, what is the speed here? Relative speed is equal to sum of the speeds. It is 36 plus 54, it is 90 kilometers per hour. Okay, it is 90 kilometers per hour, and we have to convert this in meters per second because we have the distance in meters and the time in seconds. So we have to convert this in meters per second. It is 90 into 5 by 18. Okay, 18 into 5, it is 25 meters per second. Okay, and if they are moving in same direction, what is the relative speed here? It is 54 minus 36. It is 18 kilometers per hour. Again, we have to convert this in meters per second. It is 18 into 5 by 18. It is 5 meters per second. Okay, we have to find the time taken by both the contestants if they move in opposite direction. Time taken is equal to distance divided by speed. Distance is 5000 divided by speed is 25 meters per second. It is 5 into 5, 5 into 1000, okay, 5 into 200. Okay, this is the time taken when they move in opposite direction. Okay, it is 200 seconds. And what is the time taken if they move in same direction? It is distance divided by speed is 5. It is 1000 seconds. And we have to find the difference between these two times. So the difference is equal to 1000 minus 200. It is 800 seconds. It is second option. Next one. Ramesh and Naresh start running on a circular track of length 1920 meters from the same point simultaneously in the same direction with a speed of 40 meters per second and 64 meters per second. This is a circular track. Ramesh and Naresh, they both are moving in the same direction with different speeds, that is 40 meters per second and 64 meters per second. After how much time from the start they will meet for the first time anywhere on the track? If they are moving in same direction, what is the relative speed? It is difference of these two. It is 64 minus 40. It is 24 meters per second. We have to find the time taken if they are moving in same direction. So here time is equal to distance divided by speed. Distance is 1920 divided by speed is 24 meters per second. Okay, it is 6 into 4, 6 into 320, 4 into 80. So the answer is 80 seconds, third option. Next one. A thief started running at a speed of 12 meters per second. After running for 10 seconds, a policeman started running to catch the thief in the same direction at a speed of 14.5 meters per second. Okay. See, a thief started running from this point A. Okay. He ran for 10 seconds. He ran for 10 seconds and he reached point B. Okay. He ran for 10 seconds. Okay. And after he reached point B, a policeman saw him and he started chasing the thief. Okay. This is the thief and this is the policeman. Okay. So they both are moving in same direction. Okay. And the speed of the thief is 12 meters per second. Speed of the thief is 12 meters per second. And the speed of the police is 14.5 meters per second. What is the time taken by the policeman to catch the thief? So this is the point we will imagine. At this point, the policeman will catch the thief. So we will assume thief ran for a distance D. Okay, he ran from B to C and policeman ran from A to C in the same time. Okay, policeman ran from A to C in the same time and thief ran from B to C in the same time. Okay, the time taken is same. See, what is the distance from A to B? What is the distance from A to B? See, the thief ran for 10 seconds. Okay, the thief ran for 10 seconds from point A to B. What is the speed of the thief? It is 12 meters per second. That means in 1 second, he ran for 12 meters. Okay, for 10 seconds, he ran for 120 meters. So the distance from A to B is 120 meters. Okay, so the distance traveled by policeman is 120 meters plus D. It is A to C. It is 120 plus D. And the distance traveled by thief is what? It is D. So the distance traveled by policeman is 120 meters more than the distance traveled by the thief. So if we subtract the distance traveled by policeman and distance traveled by thief, we will get 120. Okay, what is the distance traveled by policeman? Distance is equal to speed into time. We will find out this. What is the speed of the policeman? Speed is 14.5. And what is the time taken by the policeman? It is T. Minus, what is the speed of the thief? It is 12. And what is the time taken by the thief? It is T. Okay, this is equal to 120. So 2.5 T is equal to 120. So here T is equal to 120 divided by 2.5. It is 1200 divided by 25. Okay, this can be written as 12 into 100, 25 into 4. It is 48 seconds. It is fourth option. Next one. Two trains running in opposite direction cross a man standing on a platform in 30 seconds and 15 seconds respectively. See, one train is moving in this side and there is a man. A man is standing on the platform. Okay. So first train of length L1. Okay. Traveling with a speed S1. Okay. And he crossed the man in 30 seconds. The time taken is 30 seconds. Okay. So distance is equal to speed into time. Okay. So here distance is what? That is length of the train. It is L1 and is equal to speed of the first train. It is S1 into 30. Okay. It is 30 S1. Okay. And the second train, this is the man standing on the platform, and the second train is crossing the man in 15 seconds. Okay. The time taken is 15 seconds and the length of the second train is L2 and the speed it is traveling is S2. Okay. So here again distance is equal to speed into time. What is the distance traveled by second train? It is nothing but length of the train. It is L2. L2 is equal to speed S2 into 15. Okay, that is 15 S2. Okay, and if both the trains cross each other in 25 seconds. See, if both the trains are crossing each other in 25 seconds. Okay, so here again distance is equal to speed into time. What is the distance here? If two trains are crossing each other, what is the distance here? It is nothing but sum of the lengths of the train. It is L1 plus L2 is equal to speed. Relative speed will be S1 plus S2. Okay, it is sum of speeds. It is S1 plus S2 into time. Time is 25 seconds. Okay, see here L1 is equal to 30 S1 and L2 is equal to 15 S2. We will substitute this. It is 30 S1 plus 15 S2 is equal to 25 S1 plus 25 S2. Okay, we'll get here 5 S1 is equal to 10 S2. Okay, S1 divided by S2 is equal to 10 by 5. It is 2:1. Okay, the ratio of the speeds is 2:1. Third option. That's all for this video. Thanks for watching.